So, what is the efficiency of a Carnot engine? Eta equal to 1 minus theta 2 by theta 1, where theta 2 greater than theta 1 and both theta 1 and theta 2 are in Kelvin. Now, if we want to increase the theta, that means if we want to theta tends to increase, this is our aim. So, what are the process? The process is either theta 2 tends to decrease or theta 1 tends to increase, because from this expression we see if theta 2 decrease, eta also increases. If theta 1 increase, this term decreases. So, ultimately efficiency is increases. So, which process should we follow so that we get the maximum efficiency? Suppose now d eta by d theta 1, keeping theta 2 constant, what will we will get theta 2 by theta 1 square. D eta by d theta 1, keeping theta 2 constant, we will get theta 2 by theta 1 square. We are taking the magnitude. Similarly, d eta by d theta 2, keeping theta 1 constant, what will be the value? 1 by theta 1 magnitude. So, d eta by d theta 1, keeping theta 2 constant, by d eta by d theta 2, keeping theta 1 constant, take the mod, I will get theta 2 by theta 1. Just doing the ratio. Again, theta 1 greater than theta 2. That means theta 2 by theta 1 less than 1. That means d eta by d theta 1, keeping theta 2 constant, is less than d eta by d theta 2, keeping theta 1 constant. So, if we keep theta 2 constant and vary the temperature of the source, that is theta 1, then the efficiency change will be less than the theta 1 keeping theta 1 constant if we vary theta 2. So, for better efficiency, we will do theta 2 tends to decrease, keeping theta 1 constant. It will give better efficiency. Okay. Now, I am coming to refrigerator. If we run the Carnot cycle in a direction opposite to that of heat engine, that means this was the Carnot engine, heat is extracted QH here and heat is rejected QC here. This is Carnot engine, QH is heat extracted from here, QC is rejected here. But we have already mentioned Carnot engine is a reversible engine. So, if we reverse the process, A, B, C, D, what will happen? Then it will extract heat from here QH and reject heat here QC. So, there will be heat extraction from the sink which is at lower temperature and rejection of heat at the source which is at higher temperature. It is kept at theta 1, at theta 2, theta 1 greater than theta 2. So, if we run the Carnot cycle in a reverse direction, as Carnot cycle is a reversible cycle, what will happen? The net effect is the extraction of heat from the sink and rejection of heat into the source. And so, this is called the refrigerator. So, what is the purpose of a refrigerator? In the closed container, it will extract heat and reject it to the outside which is at high temperature. So, schematic diagram of a refrigerator like this. This is hot reservoir, this is cold reservoir, theta 1, this is kept at theta 2, it is extracting heat QH from here, rejecting QC here. But the problem is that we know actually heat flows from hot to cold. So, for reversing this process, that is heat is flowing from cold to hot, you need an external agency. So, this agency will force to flow the heat from cold reservoir to hot reservoir. So, without any external support, heat automatically cannot flow from cold to hot. So, to flow the heat from cold to hot, you have to supply energy. This is the work done. To get the work done is that what is the value of the Q1 minus Q2. This is the work done. This amount of work done is to be, we are not getting this work done as we get in the heat engine. Here we have to supply this energy or work done for transferring the heat from cold reservoir to hot reservoir. So, any device removing heat from cold place and adding it to another a hotter place is called a refrigerator. Carnot cycle running backwards can act as a refrigerator. Here external agency is used to satisfy the process. So, Q1 equal to Q2 plus W or W equal to Q1 minus Q2. If we take common Q2, Q1 by Q2 minus 1 is equal to Q2 theta 1 by theta 2 minus 1, as Q1 by Q2 is equal to theta 1 by theta 2 for Carnot cycle, as W is equal to 1 minus Q2 by Q1 is equal to 1 minus theta 2 by theta 1. This is valid for Carnot cycle. So, Q1 by Q2 is equal to theta 1 theta 2. If this true, so W2 equal to Q2 by theta 1 by theta 2 minus 1. This is one form of work done in case of a refrigerator. One important parameter is defined in case of a refrigerator, cooling ratio beta. It is defined as Q2 by W. Q2 by W, here Q2 means QC, Q1 means QH. Okay. Q2 means QC, Q1 means QH. Q2 by W or QC by W. So, QC by QH minus QC. So, 1 by QH by QC minus 1. So, that means theta 2 by theta 1 minus theta 2. This is the cooling ratio. So, beta equal to theta 2 by theta 1 minus theta 2. So, cooling ratio means amount of heat extracted from the cold reservoir, amount of heat extracted from the cold reservoir for per unit supply of energy, and the term becomes theta 2 by theta 1 minus theta 2, where theta 1 greater than theta 2. All the time we have to write this term theta 1 greater than theta 2. Suppose if theta 2 tends to decrease, theta 2 decrease, then that means beta tends to decrease. That is why refrigerator stops after a period where theta 2 becomes very low. This is the cooling ratio. If theta 2 tends to decrease, it is the purpose of a refrigerator for cooling within the closed chamber. Suppose we are extracting heat from the cold chamber. So, if theta 2 tends to decrease, then beta cooling ratio decreases, and that is why refrigerator stops after a period when theta 2 becomes very low, as then beta tends to decrease. It is not our aim from that the efficiency or cooling ratio of the refrigerator decreases. So, after a certain time, when the theta 2 is very much lowered, then it is refrigerator stops automatically, so that temperature in the closed chamber rises and we can get higher cooling ratio. So, this is the purpose of a refrigerator. Refrigerator acts as a room heater also. Beta, suppose QC by W, suppose QC by W equal to 5. So, 5W amount of heat is extracted from the cold reservoir. Then what we are getting from this equation, QH minus W by W is equal to 5, as QH minus QC is equal to W. So, QC is equal to QH minus QC is equal to W. So, QC equal to QH minus W. From this we get QH by W is equal to 6. So, 5W amount of heat is extracted from the cold reservoir and heat rejected at the environment or the surroundings is 6W. So, if we keep a refrigerator in a room, what will happen? It will reject heats, and more heat is rejected than it is absorbed from the cold reservoir. So, it will increase the temperature of the room.